Physics is the science of matter and energy and their interactions. It is the basis for how we live and governs the world's functionality. But how can something defy all physics-written laws and still be used for computer computation? This is quantum computing.
But let's talk about what the word quantum really means. Quantum refers to anything atomic or subatomic, but their properties go against normal limitations of physics. And in order to manipulate these particles to be used, they have to be extremely cold and extremely small. Cold because once atoms are given heat or energy, they become excited and begin hard to control. These atoms contain enormous amounts of energy, so the practice of hitting them with microwaves to manipulate their characteristics so that we can use them is called measurement. By doing so, we create something called a qubit. These qubits are what are used as the fundamental units of data for quantum computing.
Now, let's compare a classical computer to a quantum computer. In a classical computer, they contain something called a bit, which can either be a 0 or a 1 value. This allows for 16 possible combinations. However, in a quantum computer or quantum system, they have something called a qubit, which can either be a 0 value, 1 value, or both at the same time. This is done through a process called superposition. Superposition is the ability for a quantum system to be in multiple states at the same time before being measured.
There are gates that can control the behavior of a qubit by altering its energy once measured. The two most important gates are called the Hadamard gate and the Siare gate. The Hadamard gate alone allows for superposition because it transfers all of the qubit's energy to the equator, which means it has an equal chance of either being a 0 or 1 and a possibility of being both. When you add a Siare gate, you create one of the quantum's biggest phenomena, entanglement. Entanglement are when two qubits are molecularly connected to each other and they can communicate instantaneously regardless of distance. This allows for endless possibilities which include new creations of medicine, the promise of breaking some of the world's strongest encryption algorithms, the prediction of natural disasters, and etc.
Due to many discoveries in quantum computing, scientists often have conflicting views regarding certain topics in quantum computing. However, as we advance towards the future, there will be many breakthroughs in quantum computing that will ultimately change the world.